So I want to welcome you to the test review slides for test number 2. We're going to go over some of the slides from the test development lecture. Again, I want to remind you that these review slides are presented as not an exhaustive review of everything that's on the test. If you're really wanting to make sure that you do well on the test, I strongly suggest that you go through every item on the study guide, make sure that you know how to do the various activities and or explanations that the study guide lists, and that you know the definitions from the study guide, and also the names of the various people that are responsible for the test. So what are they famous for? Who made this test? What test was it? And all of those are on the study guide. These are provided as simply an additional resource where I kind of hit some of the high points of things that I think were important from each lecture. Again, that doesn't necessarily mean that there aren't things that I'm leaving out of these review slides that aren't still relevant for the test. So anyway, let's proceed, and I'm just going to briefly hit some of these main points from this particular lecture. So I did want to talk a little bit about the importance of test development and the model of test development we talked in class, the 5 stages of test development. And again, this is just kind of an umbrella concept to talk about the continuing process that's necessary in order to actually determine if you have a reliable and valid test. And that each of these phases are important and there's an order to them. So test conceptualization is that initial definition of the construct. So determining what actually are we trying to capture with this test. Once we have that, and the better that we have a definition, the better that construct defined is, the easier the rest of the process is going to be. Our second step is test construction. So we're actually creating the test. We're creating a pool of items. We're then determining which items we think are going to be a good representation of what needs to be measured in order to capture the construct that we generalized or created or defined in the test conceptualization stage. Once we have a constructed test, we're going to actually do tryouts. So we're going to give the test to people. We're going to do item analysis. We're going to look for consistency for the test. We're going to look, does the test actually differentiate the way we expect it to? So all of the various methods that we talked about prior in this class about how we test for reliability and validity is being tested for in this test tryout phase. The analysis is when we actually determine how successful is the test as a whole, but also how is each item relating to the rest of the test. If all of those factors in the analysis point to a solid test, we may be done. However, more likely, we're going to identify some problems. Some items aren't working the way we expected them to. Maybe the test is too hard. Maybe the test is too easy. Maybe the test is missing items, which leads to revision, and then further test tryout. Now, once you even finish this process, that doesn't necessarily mean that you're done. So you have a completed test. You've gone through the 5 stages: test conceptualization, test construction, test tryout, analysis, and revision. But also remember that we do need to renorm tests. We need to adjust them as cultural norms change, language norms change. So there's always going to be that additional loop occasionally of revising the test again, trying it out again, more analysis until that test is back to doing what we expect it to do. We talked briefly about test construction, and under test construction we actually dealt with a lot of issues of how to write test items to get at, again, a closer measurement of whatever the true score is of the construct we want to measure. So the better worded the items are, the more systematic we are in writing them, the more we're worried about how we're writing them and avoiding various errors, the more likely it is that we're actually capturing the construct, whatever that construct is we're interested in. And a common test item is the multiple choice item, which has the STEM, which is the actual question itself, the correct alternative, and then several incorrect alternatives. And again, a good STEM is easily understood. The correct alternative is clearly the option that is the correct answer, but the incorrect options also are important. If they're too easy or too clearly wrong, you've made a very, very easy item. However, if all of the items are nearly correct, you've probably made a very difficult item. So other commonly selected formats include matching, true and false. There's a lot of different ways to write items, but we wanted to focus just briefly for a moment on the multiple choice because that's the one that's most commonly used in a lot of the assessments that we talked about in later lectures. So again, with survey formats, so deciding how the questions are going to be actually formatted, Forced choice means it's a selected response. So questions require respondents to select from a limited number of answers. And one of the main things we focused on that was that whenever we have a forced choice question, we need to make sure that the answers are exhaustive and mutually exclusive. In other words, each option, either A, if you're only selecting a single option, those options should involve an exhaustive list of all possible responses that someone would want to respond to this item, and they are exclusive to where you'd only choose one. Or we need an exhaustive list again that isn't necessarily mutually exclusive, but people could choose multiple items. Another common response format is basically attitudinal scales, and the most common one for that is the Likert scale, where people basically are responding on a strongly agree to strongly disagree scale, usually numerical between 1 and 5 to 1 to 7, though they can be shorter or longer. And we're measuring their endorsement of a factual statement. So, I am satisfied with the computer software I'm using. Strongly disagree to strongly agree. So someone that wrote down a 7, strongly agree, is someone that is very satisfied with that product. Someone that writes down a 1 is very unsatisfied with that product. Another way to do measurement in this way is to try to capture 2 items at once, and this is a little different than double-barreled questions. If you remember, double-barreled questions are when we ask a question that basically has 2 components that someone could basically agree with half of the question but disagree with another half, which means if there's only one response option, for example, a Likert scale 1 to 7, which item are they going to pay attention to? So an example of a double-barreled item that we used in the homework assignment, for example, is the Cubs and the Cardinals are great teams. Strongly agree to strongly disagree. Well, if you agree that both are good teams, that's easy to answer. If you agree both teams are bad, that's easy to answer. But what if you think that Cubs are awesome, but the Cardinals aren't? What do you respond? So that's a double-barreled question. A semantic differential scale is purposely creating a question that has polar opposites so that we can measure 2 things at once. So, for example, each pair of adjectives place across the point in which they reflect the extent to which you believe these adjectives describe yourself, or in this case, a policeman. So if you thought people were clean, that means that they're not dirty. You really can't be both at the same time. And this is, again, that idea of a mutually exclusive scale. But it's also giving us 2 pieces of information with 1 question. We're getting both a representation of how dirty you think the person is and a representation of how clean the person is. We also talked about response brackets. Basically, if we want to break up complex data into groups, sometimes we just want to identify the groups that we're interested in looking at. So if you're really interested in hourly rates, but what you're really interested in is basically everyone that's making over $25 an hour, you might create brackets. Instead of asking people how much do you work, how much do you make an hour, to where you would then have to put them into categories, you can actually just create the response options into the brackets that you care about for your research question. And we also talked about Gutmann scales or cumulative. So again, this is an idea of both mutually exclusive to a degree, but in one direction, and cumulative. So generally, these are, again, trying to measure attitudes, and they're usually, you basically collect a series of statements that each additional statement would be true, including the items behind it. So if you selected the 3rd item, are you willing to permit immigrants to live in your neighborhood? De facto, that means you would have also agreed with them to live in your community and your country, because to be in your neighborhood, they would have to live in both of those as well. So again, this is an idea of a Gutmann scale, often also referred to as a cumulative scale. Survey formats also are whether or not items are, instead of forced choice, they can also be open-ended. So that includes fill in the blank, short answer, and generally speaking, there's advantages and disadvantages to open-ended versus forced choice. The advantage to open-ended is that an open-ended question allows for detailed responses. You can get more information, and often you don't have to worry about coming up with an exhaustive, mutually exclusive list of options, because it is now open-ended. You're not providing the options, the respondent is. The downside to these types of questions is that, generally speaking, they're harder to code, and you need experts to actually grade the information people are providing. The advantages to forced choice questions are that you can easily grade these. Often they can be graded automatically. You can basically set a computer up to grade them. There's no ambiguity in the responses. There's no judgment calls being made by experts. You don't need experts to grade them. The downside is that the question itself needs to be more carefully worded. You have to worry about, are my response options exhaustive and mutually exclusive, for instance. You also have to worry a little bit more about how you word the questions, because with an open-ended question, someone can even communicate, well, here's my answer, but. So, for example, if you had a forced choice question, again, a double-barreled question, the Cardinals and the Cubs are both great teams. Agree to disagree. In a forced choice options, they're going to have to make a choice, and that's all they can do. If that was an open-ended question, the person could actually write in, well, actually, I think the Cardinals are one of the greatest teams of all time, and I think the Cubs haven't won the World Series since before the Titanic sank. That allows someone to basically get around a badly worded question by giving you an answer that still gets the information you want. So forced choice requires you to be a little more careful in how you word your questions. Another thing we can look at in survey format is actually making the surveys easier for people to take, which includes basically filter or contingency questions. So basically, have you ever done this behavior? And if you haven't, well, you can skip these questions that are about that behavior. We also just talk about survey response formats based on how we collect information. So for example, we can have check a box, fill in a bubble, circle your right response, fill in the blank, short answer. All of these are, again, things we want to ask about. Ask, how do we actually want people to interact with our survey? And generally, our main focus in response format is simply providing the response format that is the easiest to understand and the easiest to use for our respondents, the people taking the actual survey. We are worried about floor and ceiling effects. The end result for any of our questions is we want to be able to find variation between people's responses and to be able to differentiate between people that either have a lot of whatever the construct we're measuring, a moderate amount of the construct we're measuring, or a minor amount. So we do want to make sure that we ask questions in a way that's going to give us variability. So if we ask a question, for example, I would like to have $1 million as a measurement of maybe greed or the importance of money to someone, that's not a really good question because pretty much everyone is going to agree with that item. Even people that are billionaires probably would say, well, another million couldn't hurt. Now, you might want to make it a more question that would be more variable dependent on how much you actually value money. Something like an example of, I'd be willing to tell a harmless white lie for $10. You'd probably find more disagreement there, which means that you start to get variability, so you can start differentiating between people based on their response. We can also find floor effects where basically everyone's going to disagree with an item. So material wealth is the only thing that's important to me. Well, very few people are going to agree with that. But again, we could reword it. Material wealth is important to me. Then we're probably going to see a little bit more disagreement. So additional tips for writing questions. We want to ask ourselves, will participants have the information? So a lot of times, people will ask questions that are relevant to their research, but are something that most people wouldn't have access for. If I asked you, what was your ACT score? If you've taken the GRE, what score did you get on the GRE? What were your scores in the subtest? And what's your current GPA? Some of you may actually be able to call up that information immediately. A lot of you probably would go, I have no idea. I would have to look, or I can take a general guess. A lot of surveys often ask, what's your take-home yearly salary? Some people know that number off the top of their heads. Some people could answer what their hourly salary is or what their average paycheck is, but may not really have in their mind how much they actually make a year. So you do want to ask yourself, will my participants have the information, or am I asking them to make some guessing? And if I'm guessing, if they're guessing, I'm not getting as good of responses. You also want to be careful about eliciting certain responses. So we kind of talked about this. When you have loaded or leading questions, loaded questions are filled with emotional adjectives. Leading questions basically tell you what is the socially acceptable way to respond to an item. So a leading question is, how upset would you be if your friend smoked pot? Right there, it tells you that you're supposed to be upset. The first example, should an increase in income tax, which would place an additional burden on the poor, happen? Again, we're loading it. We're talking about how you should actually respond. Also, loaded questions often are just using such terms as very, poor, underprivileged, words that basically are going to elicit kind of a sympathetic response. If you're trying to show people are more sympathetic than they are, these words are fine. But if you're really wanting to get at, are people willing to increase income tax to go towards a group of people, you want to avoid these kind of loaded terms. We also talked in class about how order effects occur, that if you ask a series of questions, you start to prime someone to think in those terms, which means you're going to affect how they respond to later questions. Anchoring effects occurs whenever you're asking people to come up with an ambiguous number. They'll often anchor their response based on the last numbers they saw. So if you have questions that have numbers in them, you'll find those numbers will influence further questions if you ask people about questions that require numbers. And we've already talked about double-barreled questions, questions that are asking two things at once. So we talked also about, beyond reliability and validity, basically looking at item analysis. And some of the things we talked about, for example, was item difficulty. What is a reasonable range for difficulty depends. Different items, sometimes we want easy items, sometimes we want moderate items, sometimes we want difficult items. But the item difficulty is P, and that P is generally just the percentage of people that get that item correct. So a high P, 0.90, means 90% of people get that item correct. It's very easy. A P of 0.10 means only 10% of people get that item correct, and that's a very difficult item. We also talked about item discrimination. So D, it's like kind of convergent or predictive validity, but on an item level. It's asking how much does this item actually discriminate between top and bottom performers. And generally we want to see a D of 0.35 or higher. So it's got a pretty good chance to discriminate between your top and bottom performers. So generally, almost any time we're creating a test, one of the things we want to do is predict performance on some form of life outcome, whether it's work performance, whether it's psychological function, whether it's academic performance. So how does each item predict that outcome? So item discrimination indexes also measure internal consistency. So the higher the overall D, so if you actually calculate the D for each item, and then create an overall average D, in other words, a mean of all the discrimination scores, that also suggests a good internal consistency. In other words, it's fairly similar to R. The higher that overall D, the more internally consistent that test is. The more each item is fairly good at predicting whether someone is a top or bottom performer. We went through two equations for calculating discrimination. So the first one works really well when the upper and lower half is the same. In other words, we have an equal number of people that were bottom performers and top performers. And then we simply look at the number of people that are top performer or underperformers, basically that are, upper performers. They're the ones that perform well. So correct U is upper performers. So in this case, 30 of the people that were upper performers got this item right out of 50. Additionally, there was 15 people from the lower group that got this right. And again, out of 50. So U and L are considered to be equal. So we can put then into the equation, since the underperformers and the underperformers total, the total number that took this test, are the same, the bottom of the equation is simply the number of people that were in the upper group. But it would be the same as the number of people in the lower group. And then at the top of the equation, we take the number of that people got it correct, the number of people out of that 50 that got that item correct out of the group that's expected to do well, minus the number of people that got it correct from the group that was expected to do more poorly. So in this case, we've got 30 people that got it right out of 50 in the upper group, 15 that got it right out of the lower group. 30 minus 15 is 15. 15 divided by 50 is a D of 0.30. So this item somewhat discriminates between top and bottom performers, but it's less than that 0.35 we talked about in the last slide. So this is not a great discriminating item. This equation is basically another equation to do the exact same thing. We're calculating D, but in this case, it's different in that we have a different number of people in the groups. So we have, again, our upper performers, the people that are expected to be doing well. These are the people that we've already pre-identified with some other measure as top performers, maybe previous grades, maybe previous performance appraisals. So in this case, we have 50 people in that group, and of that 50, 30 actually performed well. They got the item right, so 30 out of 50. So the first half of the equation, 30 over 50. Then we subtract from that the number of people that got it right divided by the total number in the lower group. So in this case, there were 100 people that were actually from the underperforming group, the lower group. And only 15 of those 100 got it right. So 15 divided by 100. If we run the math, 30 divided by 50 is 0.60. 15 divided by 100 is 0.15. 0.60 minus 0.15 equals a D of 0.45. In this case, because there was a lot more people in that underperforming group, the lower group, we actually have an item making a decent discrimination of 0.45. We also finally want to discuss utility briefly. So whenever we're actually looking at a test, beyond whether it's reliable, beyond whether it's valid, beyond whether it discriminates, we also want to ask is how practical or valuable is the test at improving efficiency. In other words, how much does it cost to use this test? And by using this test, how much money are we saving? So factors that affect utility include psychometric soundness. So generally, the more the test predicts the outcomes that you're interested in, the more reliable the test is, and the more valid the test is, it's going to be more likely to be high in utility. But there are exceptions because many factors affect the utility of an instrument, and utility is assessed in many ways. So valid and reliable tests are not always useful tests, especially when they're very difficult to administer or very expensive to administer.